Welcome to The Explainer. Today, we are diving into a massive leap in AI. You see, we've gotten used to AI that can answer our questions, but now we're stepping into a whole new era, the era of AI that actually takes action. This is the world of AI agents. So here's what we're going to do. We're going to build our understanding from the ground up. We'll start with what an agent even is, then we'll peek under the hood to see how it's built, and then we'll look at how it actually thinks. From there, we'll explore how these agents are evolving from pretty simple tools into something much, much more powerful. And finally, we'll touch on why all of this really matters.
You know, this quote just absolutely nails it. Think about it for a second. Language models have been these incredible, powerful brains, but for the most part, they've been kind of stuck in a box. Agents are the key that unlocks that box, connecting that brain to the real digital world and letting it finally get things done.
Okay, so let's dig into our first big idea. This huge shift from just getting answers to actually taking actions. And I really want to be clear here. This is not just some minor update. This is a fundamental ground-up change in how we're going to build and interact with AI from now on.
And this slide gives us the perfect analogy for that shift. You see, traditionally, a developer has been like a bricklayer, meticulously planning and placing every single line of code, every logical step. But with agents, that role completely changes. The developer becomes more like a movie director. You're not laying the bricks anymore. Instead, you set the scene. You give your actor some props, the tools, and you give them the high-level goal. Then you let this autonomous actor go and build the wall for you. It's a really powerful change from managing code to managing outcomes.
So, if these agents are autonomous actors, what are they actually made of? Let's take a look at the anatomy. It really boils down to three core parts.
And honestly, the best way to think about these components is with a simple human analogy. You've got a brain for all the reasoning, you've got hands to actually interact with the world, and then you've got a nervous system that connects the two and makes it all work together.
So first up, you have the model. This is the brain. This is your large language model. Think something like Gemini that does all the heavy lifting. It's the core reasoning engine that processes information, thinks through complex problems, and ultimately makes the decisions about what to do next.
But, a brain is pretty useless if it can't interact with the world, right? That's where the tools come in. These are the agent's hands. And this can be almost anything: an API for a search engine, a calculator, a function that lets it access your company's private database. These tools are what allow the agent to go beyond its static, pre-trained knowledge and actually take action in the real world.
And the final piece of the puzzle is the orchestration layer. This is the nervous system. And this part is absolutely critical. It's the process that links the brain and the hands. It's like the conductor of an orchestra, managing the whole flow, breaking down big goals into smaller steps, and deciding, okay, now's the time to think, and now's the time to act and use a tool.
Okay, so we've got the brain, the hands, and the nervous system. How do they actually work together to solve a real problem? Well, it all comes down to a simple but very powerful repeating loop. It all works on this continuous 5-step cycle. Let's imagine a customer support agent. A user asks, "Hey, where's my order?" That's step 1, get the mission. Now the agent doesn't just guess. It scans the scene, it thinks through a plan, and then it takes an action. Maybe step 1 is using a tool to query the order database. Then it observes the result, finds a tracking number, and iterates on the loop, this time using a different tool to check the shipping status with that number. This think, act, observe cycle just keeps repeating until the mission is complete.
Now, of course, not all agents are created equal. It's kind of like vehicles, right? You've got everything from a simple bicycle all the way up to a rocket ship. We can actually think about agents in 5 distinct levels of capability, climbing a ladder from pretty simple to, well, superpowered.
So at the very bottom of the ladder, we have level 0. This is really just the brain, the core language model sitting in a vacuum. It has this vast amount of knowledge it was trained on, but it has absolutely no connection to the live real world. It's basically blind and deaf to anything that's happened since its training was finished.
And this right here is the perfect example of the difference. A level 0 agent can write you a beautiful essay on the entire history of the New York Yankees, but it has no earthly idea who won last night's game. But you give it one simple tool, a connection to a search engine, and boom, it becomes a level 1 agent that can get you the score in seconds.
So level 1 is really the first true step into agentic systems. This is where the brain finally gets its hands, and that allows it to connect to the outside world and solve problems using current, up-to-the-minute, factual data.
At level 2, the agent becomes a strategist. It's not just reacting anymore, it's actually planning ahead. So if you ask it something complex like, find me a good coffee shop that's halfway between my house and my office, it's smart enough to know this is a multi-step problem. First, it'll use a map tool to find the midpoint, and then it will use a different tool, like a business search, to find highly rated coffee shops in that specific area. That's strategic, multi-step thinking.
Level 3 is where things get really interesting, because this is a huge leap. Here, we basically stop trying to build one single, all-powerful super agent. Instead, we create a team of specialists, where different agents, each with their own unique skills, can collaborate and delegate tasks to each other, kind of like a real human organization.
And here's a great look at it in action. You could have a project manager agent that you give a really high-level mission to, like launch our new headphones. It then breaks that huge goal down and delegates the work. It tasks a market research agent to analyze competitors, it hands off press release writing to a marketing agent, and it tells a web dev agent to build the product page. This is where you can start to automate entire complex business workflows.
And finally, we arrive at level 4. This is the true frontier of agentic AI. This is where the system becomes self-improving. So imagine an agent system realizes it has a gap in its own skills, like maybe it needs a new agent that's an expert at analyzing social media sentiment. A level 4 system can actually build that new agent for itself on the fly. It's a system that truly learns, adapts, and grows on its own.
Now, as you can probably imagine, this kind of incredible power and autonomy, well, it also brings some huge new challenges to the table. And some of the most pressing ones are all about security and control.
Security is a massive one here. You see, right now, our digital security systems are basically built for two kinds of things: human users who log in with a password or Face ID, and simple, predictable background services. But agents create a brand new category, right there in the middle. They are autonomous actors that we give permission to act on our behalf. That means we need a completely new security playbook to make sure these agents have a verifiable identity and can't go rogue. That's what complex standards like SPIFFE are trying to figure out.
And that really brings us to the most mind-bending question of all. If an agent can create other agents, what happens next? This isn't just the next chapter for software development. This is a potential revolution in how we create, how we innovate, and how we work. It is a frontier that is expanding by the day, and one we are definitely going to be watching closely. Thanks for joining us on The Explainer.